Okay, let's take a look at this question here that involves looking at a lot of things to do with our inverse trig. The first part we've already done. And we can do it, if you weren't sure, just about looking at the whole side length, which is 4, whole side length up there, can't draw up that far, and just using tan, it's just essentially looking at the difference between them. So we've got the inverse tan of 4 over x, which is the long side, minus the inverse tan of 3 over x, which is the small angle. Subtract the two of them, you get that there. Things get difficult when we're asked to show that the angle is maximized when the viewer is 2√3 meters from the wall. This means that I'm going to need to differentiate this expression because I want to show that it's a maximum, and I can show it's a maximum when the first derivative is equal to 0. That means it's going to be a stationary point, and then I can test either side. I could look at the second derivative, but this is going to be a bit of a monster anyway, so I want to avoid doing that. So let's look at this way. We're going to differentiate both of those terms. Now we know that the derivative of the inverse of tan is going to be the derivative of what we have inside my bracket there. Now I am going to write this as 4x to the negative 1, just because it's going to allow me to operate with it a little bit easier. So let's differentiate the first term. It's going to be negative 4x to the negative 2 over 1 plus 4x to the negative 1 squared. And on the other side here, we're going to have minus negative 3x to the negative 2 over 1 plus 3x to the negative 1 squared. Now I'm going to expand both those squares out the bottom there. 1 plus 16x to the negative 2. I'm going to keep these in brackets for the moment, just because I know we've got lots of negative powers everywhere, but if I clean up what I need to first, it's going to be easier to operate with them. I'm just going to make those two negatives there. It's like a smiley face. Two negatives there are positive. Now, I'm going to rewrite this first expression. Let's rewrite it as negative 4 over x squared divided by 1 plus 16 over x squared. Negative 4 over x squared divided by x squared plus 16 over x squared. And you can already begin to see what's going to end up happening here. When we divide, we flip the sign, turns into a multiply, times x squared over x squared plus 16. They're going to cancel, and we're left with negative 4 over x squared plus 16. Oh god. Let's do the same to the other side here. Plus 3 over x squared divided by 1 plus 9 over x squared. Same thing, plus 3 over x squared divided by, get that common denominator in the denominator, plus 3 over x squared times flip it, just like what we did to the other side. A lot of similarities in these questions here. Over x squared plus 9. We're good, we found the derivative. It wants to show that it is maximized when they are 2√3. So when x equals 2√3, we want to show that's a maximum. Well, to show it's a maximum, I need to show that it is essentially a stationary point, which means I need to solve these two expressions here be equal to 0. And I'm going to do that right now. Let's solve them be equal to 0. Add 4 over x squared plus 16 to both sides. I'm going to solve for x here. So we have 4 over x squared plus 16 equals 3 over x squared plus 9. We can cross multiply here. So we ascend down the chain. 4 x squared plus 9 equals 3 x squared plus 16. Expand them out. 4x squared plus 36 is equal to 3x squared plus 3 times 16, 48. Subtract 3x squared from both sides. Subtract 36 from both sides. And now I'm going to square root, which if I simplify root 12, gives me 2√3, exactly like it was asked. At this point here, we could find the second derivative, and then we could show that when I substitute this value of x in there, that it is a less than 0, a maximum, but it's going to make far more sense now that I've already got my first derivative. The second derivative is going to be really ugly. Now that I've got this, I can simply test. I can test a point either side of 2 root 3, which I know is 0. So I could test 1, which is going to give me a positive number, and I could test, let's just say 5, which will give me a negative number. And looking at the gradients, I can show there that it's a maximum. So I've got the value of x, I've shown that it's a maximum. The final step is asking me to show that the maximum angle subtended by the picture at E is the inverse tan of root 3 over 12. So it can be a little bit deceptive here. I've got my expression for theta here. Minus, plus, minus. Inverse tan of 3 over x. I've got that maximum value for x. What I'm going to do here is I'm going to substitute this value in. I'm going to sub it in. 4 over 2 root 3 minus the inverse tan of 3 over 2 root 3. Here, I'm going to find a common denominator. I'm going to rationalize the denominator in both of those fractions there. It's just going to make the next step after this a little bit easier. Rationalize the denominator, which means do it in a different color so I don't get confused. I'm going to times it by root 3 over root 3, and this one's the same, root 3 over root 3. So I end up in my first one with 4 root 3 over 6 minus the inverse tan of 3 root 3 over 6. That gives me, if I simplify, 2 root 3 over 3 minus root 3 over 2. This next part, I'm essentially want to show that that is the inverse tan of root 3 over 12? Root 3 over 12. This means I need to somehow combine two angles into one. And how can we combine two angles into one? It's something we looked at a while ago. It is going to be my inverse tan addition and subtraction formulas. So if we recall that the inverse tan of x minus the inverse tan of y is equal to the inverse tan of x minus y over x plus, oh no, 1, abort the mission. Good thing I can rub this out. Over 1 plus xy. So if we were to take x as 2 root 3 over 3 from our example above, and y as root 3 over 2, let's plug them into this formula right here. Equals the inverse tan of 2 root 3 over 3 minus root 3 over 2 divided by, let's make that look like a 3, 1 plus 2 root 3 over 3 times root 3 over 2. Let's clean up that numerator first. Inverse tan of, subtract these two fractions. We can essentially, we don't want to put this in the calculator, so we could look at common denominator again, times top and bottom by 3, times top and bottom by 2. So we've got 4 root 3 over 6 minus 3 root 3 over 6 divided by, I'm just going to put this in big old brackets, divided by 1 plus 2 root 3 times root 3 is 6 over 3 times 2, 6. So it's over 2. Clean it up a little bit. 4 root 3 over 6 minus 3 root 3 over 6 is root 3 over 6. That's going to be 1 plus 1, which is 2, divided by 2 gives me the inverse tan of root 3 over 12. Remember, that's just root 3 over 6 times 1 over 2. And that is the answer we are after. So that is some really high level of operating with inverse trig using the working calculus on maximum and minimums and going from there.